Okay, in this video we are going to discuss exponential functions, just kind of a brief overview. An exponential function is one where the exponent is our variable. So we're going to have some base, and that a is just going to be some number. So it could be 2, 3, 4. As long as a is a positive number that is non-zero, okay, so it's got to be greater than 0. It could be a fraction, it could be a whole number, but it's got to be bigger than 0, and also not 1. Okay. Then we're going to have an exponential function. We've got a couple of examples here. We've got f of x equals 2 to the x and f of x equals 1/2 to the x. And I've actually already got those graphs, so we'll fill in these points and then talk about which one is which here. So if we were to plug in these x's for the exponent in these, I'll start with 2 to the x, but and I'll start with some x's that we know here. If we plug in 0, 2 to the 0 power is 1. Anything at all to the 0 power is 1. 2 to the first is 2. 2 to the second would be 4. 2 to the third would be 8. And then negative exponents, remember, those turn our number into the reciprocal of that. So if I plug in negative 1, it's going to be like 1 over 2 to the first. So that's going to be 1/2. This would be 1/4. And this would be 1/8. So that is going to be this purple graph is y equals 2 to the x, where we have what's considered to be exponential growth. 1/2 to the x is kind of going to work just the opposite here. So if we plug in 0, again we get 1, and notice that they share that point 0, 1. If we plug in 1, 1/2 to the first is 1/2. 1/2 squared is 1/4, and 1/2 to the third is 1/8. So I'm getting kind of the opposite table here, in that when I plug in positive numbers, I'm getting those fractions. But then if I start plugging in negatives, then I'm going to start doing the reciprocal of this fraction, which means I'm going to get whole numbers. So I'm going to get 2, 4, and 8 working this way, and we get 1/2 to the x gives us this function, which is exponential decay, which means it is going to go down as we go to the right. Okay, so just in general, graphs of exponential functions, as you can see with these two, the domain of an exponential function is always going to be all real numbers. We are going to be allowed to plug in anything at all we want for an exponent that is a real number, and we are going to get a value from that. So we're going to span the entire domain. All x's will be allowed in an exponential function. The range, as long as there are no transformations going on, if we look at these graphs and we look at our answers, no matter what we plug in, we are always going to have positive values for y, which means our range is going to be from 0 to infinity. It's going to always be positive in terms of their y values, which means there's going to be a horizontal asymptote at the line y equals 0, which is the x-axis. Okay, and again, that will change if there are transformations, but as long as we don't have transformations, then it's just a number to the x power. That is always going to be the case. There are always going to be one of two shapes. It's going to be exponential growth, which will look like that, or exponential decay, which will look like that. Okay, that's always going to be the case. Here we have graphed already f of x equals 2 to the power x, and we're going to graph each one given just transformations. So we just need to know what these transformations are doing to this. So this 1 plus on a just means that we are going to move this graph up a unit. So every single one of these points is going to be moved up 1, and we will end up with a graph that is just above this, and the asymptote for this one would be at 1 and not 0 because of that transformation being up 1. It takes our horizontal asymptote and moves it up 1 as well. So that's A. To graph B, we have a negative in front. A negative in front is going to be a reflection about the x-axis. So what's going to happen here is we're just going to, our asymptote is not going to change. We're just going to reflect it down instead of up. And we're going to end up with a graph that would do this, and again tail towards the x-axis, as we go to the left. We still have that same asymptote. So that's going to be B. And then our third one, C, is we have 2 to the x minus 1 power. So there we have subtraction on the inside with the x. And that's going to be a transformation to the right 1 unit. So if I move all these points to the right 1 unit, that is what we're going to end up with. Now our asymptote stays the same. It's still going to tail off at the x-axis, or at y equals 0. But every point was shifted to the right 1 there in order to graph that.